Okay, so in the last class we started with unfolding, that is parallel processing. We considered the example of an IIR filter. We first gave you the general idea of parallel processing. Okay, that you can if you are ready to increase the hardware by j times, then you can increase the input output clock also, clock speed also by j, or you can reduce the period by j, make it shorter. If the system is working at a clock capital T, your input output clock period can be T by j. Then I took the example of an IIR filter, okay, and then I consider the general case of unfolding a DFG, where a typical sector of a DFG is like one node U from which a edge goes out to another node V, and edge may have some delay W. Then how to unfold it? So, U will be copied parallelly j times and V will be copied parallelly j times. Now, one of the U0 will what is happening there, just for a quick recap. J number of input data or incoming data are parallelized. So, in the 0th clock, in the 0th system clock, that is under one umbrella only, input clock 0, input clock 1, input data at 2, input data at 3, input data at j minus 1. So, total j, they are parallelly coming, they are made parallel by a buffer, and they come into the system at the 0th system clock. System clock period is so much bigger because it is slow. So, like that. Similarly, fast will be having data at j, j plus 1, like that. So, the leading data, that is the 0th or j plus 0th or 2j plus 0th etcetera, will be processed by processor with index 0 like U0 or V0, like that. Okay. Similarly, data with index 1 will be processed by V1, U1, like that. Okay. Under this case, if you take any particular any particular node UR, rth copy, that means, or say ith copy, that means data is at kj plus I. From kj plus I have to go to the right by W number of system clock, input clock, because originally you are given something like this. This was the original stuff, this I cannot violate. So, with respect to original input rate, W number of W cycle of delay after being processed by U. So, after being processed by U I, because it is kj plus I, if it is kj plus 0, processed by node 0, if it is kj plus 1, processed by node 1, they are parallel. So, kj plus I means ith input line will be given to node UI, and then if you start counting W number of input cycle. So, 1, 2, 3, like that, if you go further to the right, you may be hitting here. What is this point? We worked out, that is, instead of counting from here, if you count from here, then basically you will jump to the right, not by W, but W plus this much, this I plus W. So, within I plus W, how many blocks of j? So, divide by j, quotient will be the number of cycle by which you have to go to the right. So, that many system cycle delay. If quotient is 1, from here you are going to next. So, 1 system cycle delay. If quotient is 0, no, in the same system cycle. If quotient is 1, as I told, in the next system cycle. If the quotient is 2, you are jumping to the right by 2. So, 2 system cycles, because they are coming parallelly. So, this j input data or incoming data available together, next j input data available together. Together means in the same system clock. Okay. So, small W number of input cycle means you have to move here. So, how many such system clocks? So, I plus W you take, divide by j, that is how many j's are there, take the quotient, that will be the number of clock cycle, system clock cycle by which you have to go to the right, that is you have to delay, then you hit here. And once you hit here, okay, or maybe here, okay, once you hit here, how much is this index? How much is this index? This is, because if it is 0, then I have to give it to 0th guy, because it handles the process data with 0 index, right. Like kj plus 0 goes to U0 or V0, like that. So, if it is here, data from UR after so many cycles, system cycle delay would go move to V0. So, I find out what is this much. So, this is nothing but the remainder. If the remainder is R, or say, so from UI I go to VR, with system cycle delay equal to quotient of I plus W divided by j. Then there was the formula we derived last time, and then if we see the implication of the formula, okay, suppose you start at a particular block, you start here and you have to go to the right by W. So, suppose you go to the right by W here, Okay. So many, maybe this is L, and you go to the right by 1, next, next. So, after some system cycle delay, that is, if you divide I plus W I is 0 here, it is k j plus 0, not k j plus I. So, W by j and then take the quotient, that is called m. So, after m cycle, you have to shift to the right, you have to move to the right by m cycle, and from here if you go, you are hitting this fellow, this is L. That is why u 0 going to V L, u goes to V. So, I am going to V category from u category, but which of the V? V L, and after how many system cycle delay? M. Then if you go on next, there is k j plus 1, that is I am targeting u 1, because index is 1. If I move to the right by 1, here also I go to the right by 1. So, still under the same umbrella. So, still number of cycle by which I have to go to the right is m, quotient will be m. That is, even if it is not 0 plus w, but 1 plus w by j quotient will be m, but remainder goes up to L plus 1, that is why this goes to V L plus 1 with the same delay. It will go on till a time when I hit a point, from where if I go to the right, I hit here. Maybe it is u r, maybe it is here u r, okay, u r. That is the last point, still under the same umbrella. So, delay remains m, that is r plus w by j quotient is still m, but I am hitting the last guy means j minus 1 is. So, I have got these parallel lines with m delays. Now, if I go further to the right, then I enter the starting index of the next clock. So, I need one more cycle to move further to the right. So, delay will become m plus 1, and I will hit the 0th index means I will go up to 0th processor V 0. So, from u r plus 1 I go to V 0 with m plus 1, this is m plus 1. Next also will be, if I go further to the right by 1, here also it will be going further to the right by 1. So, from u 0 I will now go to V 0, I will now go to V 1. If I go from u r plus 1 to u r plus 2, delay remains same m plus 1 dot 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 dot, finally, last point here will take me to last point here. So, this is one category, this is one category. This is the general structure of an unfolded edge. Okay. So, after this further repeated or repetition of the explanation, I hope now it will be clear to you further. Suppose as an example, this w is some integer multiple of j, some q times j, q some integer. Then what will be the structure? If you start with the timing diagram, suppose you take the kth system clock, that means this will be k j plus 0, k j plus 1 dot dot dot, k j plus j minus 1. Okay. Now, w by j quotient is q. Then if you start from here, if you cover 1 j, you are hitting the next, this is the next. If you start from 1, 2, 3 like this, finally you will hit here. Okay. So, if q is 1 and w is j, if you start at k j plus 0, you go to the 0th index or starting index of the next clock. So, one cycle delay, but u 0 goes to V 0, because 0th to 0th, then first to first, then second to second. So, it will be horizontal line u 0 to V 0, u 1 to V 1, u 2 to V 2, all with one delay. You have got q delay, you go further, like if q is 2, from here you go by one more. So, he hit the next one. So, from k j plus 0 to k plus 1 j plus 0 to k plus 2 into j plus 0 here. So, 2 system clock to the right, 1, 2. So, there will be u 0 will go to V 0, if you go to the right by 1, this also will go to the right by 1. So, u 1 will go to V 1, u 2 will go to V 2. Okay. So, there will be horizontal lines, now with delay 2, in general with delay q, that will be structure. Okay. It is just one side issue. Another interesting thing which comes from this is this. So, we are dividing w by j. In general, this will have a quotient, okay, m, and remainder, say w percentage j, which is remainder r in general. If w is less than j, quotient will be 0 and remainder will be whole of w. We all know, if w is less than j, if we divide w by j, quotient will be 0, remainder will be whole of w. Otherwise, there will be some quotient, some remainder. So, in general W then will be m times j quotient times divisor plus whatever be the remainder, right. If m is 0, W becomes R. These all of us know. Suppose this is the case, the W is given to me this, and I just want a game, I want to play a game. I want to find out total number of delays in all these unfolded edges. So, here I have got m, here I have got m, here I have got m dot dot up to m. So many m plus m plus m, so that many, and then m plus 1, m plus 1, m plus 1, so many m plus 1. So, if I add all these m's and m plus 1s, what is the total figure? Okay. I just want to count. Now, here it goes to this node, delay is m, here it goes to this node, delay is m, and then it goes up to the last node, delay is m. How many I have in this category? This is VL. Okay, it is not just a minute. In fact, I should have, it should be actually VR now, if I introduce the, because you start with 0 index in the timing diagram, you go to the right by m cycle, then you must hit the rth point, then only u0 should go to VR. So, if I call, so that means remainder should be R, that is if you divide W by J, m quotient, so m number of cycle to the right you go, and then you hit the starting point, then further by the remainder, if remainder is R, instead of L it should be R. There is V W percentage J. W percentage is R, that is why it is VR. That is why it should be V A. It should not be VL, because L is replaced by R. So, it will be VR plus 1 and dot 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 dot. Just changing the notation, all right. So, I have got R as the remainder. So, how many I have here for which the edges have m delays? I have got j minus 1 minus r. So, that will give me this many, plus you have to take this VR also. So, plus 1, j minus 1 minus r plus 1, r plus 2 up to j minus 1 you went. So, j minus 1 minus r will be this much, and then you have to take this also. That means, how many I have got? J minus 1 minus r and 1 more plus 1, right. J minus 1 minus r will give me this much, and then I have to take this also into account, because this also has corresponding edge as m delay, that is a plus 1 more case. So, how many such nodes here? J minus 1 minus r, this many plus 1. So, for all of them I have got delay m. So, that many m, and the remaining edges have got m plus 1 delay. How many of them? Total I have got j. Okay. Total I have got j, and here I have got 0, 1 up to r minus 1, because here it is r. So, 0, 1, 2 up to r minus 1. So, total is r here. Okay. You can see these two cancel. So, j minus r. So, here I have got j minus r, total j. So, remaining here are obviously r. And if you count this way, u0, u1 dot 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 u r minus 1. So, total is r. So, r times how many delay for this edges? Not m, but m plus 1. If I see what is the total number of delay when they are added in all the edges after unfolding, what is that? So, minus mr and plus mr cancels. So, what you have is j m plus r, that is all, which is nothing but this m j plus r, which is w. This is very interesting. That is, if the original delay in terms of the original input cycle in that edge is w. Now, obviously, delays in each edge going down, because you are dividing by j and then taking the quotient. So, as a number m is maybe smaller than w, this m is smaller than w, m plus 1 smaller than w. So, number of delay counts, not in terms of time, delay count. There is a figure wise m is much less than w, m is less than w, m is less than w. But when you add them, then they add up to the total w. That is, total w figure gets distributed among these edges, as smaller figures m, then m plus 1, m plus 1, m plus 1. When added, figure becomes W. But remember, W was with respect to the input clock, original input cycle, which is faster. So, here that would have been one input cycle. So, this is faster. So, you take W of them, that many delays. But now, when I say m is with respect to the system cycle. System cycle means j number of input cycle. If you take j such, then this is one system cycle, okay. This much, this is one system clock period, all right. So, in terms of time, it is same, okay. In terms of because it is 1. Earlier I had got j number of input clocks, now j all packed together and the data here are parallelly available in one system clock. So, figure has gone down from j to 1, but in terms of time, original clock had only this much width, now I have got so much width. Okay. So, in terms of time or clock period duration, each of these unfolded edges has longer, bigger clock period than the original. But in terms of the number of such clock periods, obviously it is less. M number of clock such slower clock periods, that is less than W. So, as a figure, this is less than W. And interestingly, if I just add up the figures only, it turns out to be W. Okay. Another interesting thing, suppose I have got U V and there is a W delay, and W is W number of input cycles, okay, and W is less than the unfolding factor J. Okay. J is an unfolding factor and W is not very high, it is less than J. Then what will happen in terms of system cycle, you can see if I am at a particular system cycle kth where all the data are parallel. So, this is your k j plus 0, k j plus 1 dot 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 some point, and then next one is k plus 1. So, now if I start at k j plus 0, that is if I have got u 0, and if I go to the right by W number of input cycles. So, 1, 2, 3, since W is, if W is equal to J from k j plus 0, I go to this point periodicity k j plus 0, if you start counting J, you will hit here. So, you go to the next cycle, but since W is less than J, if I count W to the right, I will not reach here, I will be either here, sorry. I will be either here, or if W is less, I will be here or here or here. So, from here I will be going to some edge, maybe VL, but within the same system clock. So, 0 system delay, 0 system cycle delay, and as you know, this will continue for a while. This will continue for a while, then you will reach the last guy V j minus 1, and then if you go further to the right, it will hit. So, here it means if it is say V r, that is you have got to k j plus r. From here if you go to the right by W, you hit the last point. From here you went here, here you went here, here you went here, like that, but you have now reached a point k j plus r. So, node is V r, that takes this data, by data is parallel. From here if you go to the right by W, you are still within the cycle, same system cycle, but hit the last point, that is why here. So, all these edges have no delay, and in this direction I have seen the general structure. If it is m, this is m plus 1. So, if it is 0, it is 0 plus 1, that is 1 delay, that you can see here also. If you now go further to the right, you hit the starting of next guy, that is V r plus 1 will take you to, sorry, u r plus 1 will take you to V r, V 0, and only 1 delay, and then like that dot 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 V L minus 1, still 1 delay. That is, you complete all the points, you hit this. Okay. So, interesting thing is that originally I had W number of delays, and W suppose is not 0, greater than equal to 1. So, really there is at least 1 cycle delay or more than that. But after unfolding, certain edges arise, these edges in this direction, which are delay free, no system delay, no delay at all. So, there the nodes come in the same cycle. Nodes edges in other directions have delay, but in one direction. This happens when W is less than J, that is the delay is less, unfolding factor is more. So, more data parallelized, so there is only some delay free paths emerge. This is another interesting thing. Okay. But this has an implication now. I will show you an implication. Suppose I have a process, just U and V, all right. This takes time t, this takes time t. Okay. So, to critical path is t plus t to t. I mean, to minimize the critical path, I do a cut-set retiming here, I put a delay, all right. So, now critical path is t, because in one cycle I do the job here, next cycle only that output is required here, it takes a time t to do operation on that time it takes time t to process next data, and like that we have been discussing this again. So, now critical path is t, but I say no, I am still greedy, I want to make it t by 2, but nothing more can be done. You cannot go inside the nodes and do anything, that is suppose not possible. So, even if you increase d to 2d, 3d, 4d, anything, it does not change the critical path is t, you have to be happy with this if you are just doing things this way by pipelining. But I say no, I still want it to be t by 2. So, if I have to be t by 2, then what I have to do is this, I take a buffer j is 2, because from t I want to go to t by 2, t by j, here t by t. So, j is 2 means I need a buffer of 2 chambers, okay, as before x of 0, x of 1, then x of 2, x of 3, even odd, that combination comes. You have got switches closing at a period of t. Now, u will be u 0, u 1. It will take x 0, then x 1 here. Next time it will take x 2, that time x 3. Next time it will take x 4, that time x 5, like that. This we have taken up this example in that IIR filter case, so I am not reading it. And rate here is t by 2. And now unfolding, so here V also becomes V 0, V 1. Now, if you see the timing diagram, the general block, suppose you have got two data, Kj, this is a Kj block, Kj plus 0, Kj plus 1. This data goes to U0, Kj plus 1 is original data goes to V0, U1, U0, U1, fine. So, after being processed, I know that after U, I have to give one input cycle delay. Okay, one input cycle delay. Remember, here it is 1, W is 1, but J is 2. So, W is less than 1, W is less than J. Here W1 means less than J, because J is 2. So, this is the case I considered in the previous case, page. Okay. So, if you start from Kj plus 0, you have to go to the right by only 1, because that is the correct situation, that is the actual situation given to me. I may do implementation in my ways, but actual thing given is output of U should be delayed by one original input cycle, then given to V for processing. So, if I start at Kj plus 0, that data is processed by U is U0 here. So, I have to go to the right by one input cycle. So, I am here. So, from Kj plus 0 I go to Kj plus 1 within the same system cycle. So, no delay is required. I give it from index 0 to index 1. So, it comes here. And from here, if I go to the right, I go to the next cycle. So, 1 delay, and from index 1 to index 0. So, U1 goes to V0, all right, but with 1 delay. Now, you see, originally I had a delayed in the edge. So, the two nodes U and V, their timings were not getting added, because they are not coming in the same cycle. There is one cycle it does the job, then gives it here in the, and then it processes it here in the next cycle. It does not depend on the same cycle here. So, it is doing job independently. Previously computed job only is used here. So, it does not have to wait till in the current cycle it finishes the job. that is where critical path was just t. But here you see this edge has got one delay, but as I told you, if w is less than j, as is the case here, edges in this downward direction become delay free. So, it is delay free, which means this time t and time t, they get added, not for this edge, but for this edge, because I have to take the edge which takes maximum time, I have to go by that, because I have to give time for that also to be completed, not only the other one. So, this edge will require t plus t 2t, okay, t plus t 2t. So, system clock cannot be made shorter than 2t. That means, instead of 2t, it will become 2t, and then 2t by 2 means t. So, what have I achieved? I have achieved nothing. Input clock period still remains t. I had first retimed it, it was giving me critical path t. So, input clock was t only, period was t. I say no, I want to make it t by 2. Somebody told, okay, do unfolding. So, I unfolded it 2 and got something like this, but I find its critical path, because the two nodes are now joining in the same cycle, the delay has gone, there is no separating delay. So, the 2 times get added, t plus t 2t. Therefore, system clock cannot be shorter than 2t. So, if it is 2t, this is t. So, input period remains t, but unnecessarily I have increased my hardware. Earlier I had 1 u node, I have got 2 u nodes. Earlier I had 1 v node, now I have got 2 v nodes. So, I am requiring double the hardware, double the power without getting anything. So, give me a minute. Let me put my mobile on vibrator mode. Yeah. Okay. So, I do not get anything. So, there is no point, you can say that what is the advantage of doing unfolding. Okay. Now, you see, while doing retiming, originally I had no delay, then I retimed, I put one delay and then went ahead with this. So, I do something more there. If instead of 1d, I give 2d, even then critical path here is t. So, input clock cannot be shorter than t, clock period, because whether it is d or 2d or 3d, that does not change anything. This is working in one cycle, taking t amount of time, it is given in another cycle here, taking t amount of time. Okay, we have done. So, this is critical path remains t, but now after doing making 2d here, after having a 2d here, if I do unfolding by same factor 2, so, I will have okay. Now, you see, if I go back to that timing diagram, if we suppose kth, I am here and here, only 2 point, kj plus 0, kj plus 1. Okay. And from kj plus 0, I have to go to the right by now 2, not 1. Now, it is w equal to 2. So, this is not correct, w equal to j now. So, if go to the right by 2, 1, another 1, so I am here. So, k plus 1th, which means I have to delay this output by one system cycle, and from 0th I go to 0th. So, it will go to V 0, but there will be a delay. Similarly, this one will go to the right by 1 and then 1 more, because it is 2. So, from index 1 to index 1, E 1 will go to V 1, but same system cycle. So, now both these edges have critical path. I mean, this system has critical path t only, not 2t, because this edge also having a delay, this is also having a delay. So, the 2 times of the 2 nodes t and t, they do not get added. So, critical path remains t. So, system can jolly well work at clock period of t. So, if it is t, it will be t by 2. So, you see, just by changing the retiming before going into unfolding, we can get our desired result. This is very important, that unfolding alone may not give you the result, because unfolding has a problem that delay count per edge goes down. Okay, that m was a quotient of w by j division. Okay, m number of delay, m plus 1 number. So, delay count goes down, and if w is not high, j is high, some delay free paths emerge. Some delay free paths emerge. Okay. In one direction I have got delay free path. So, originally edge was delayed, but now new edges come up which are delay free. Okay. So, while trying to achieve higher speed, I end up into a problem where critical path increases. So, I cannot really increase the system clock, and therefore, I cannot get that advantage at the input clock. Because unfolding has a problem that it always leads to reduction in the number of delays in the unfolded edges. And if W is less, original delay W is less than J, then each edge will have delay free. I mean, some of the edges will be delay free, and some other edges will have delay 1 if W is less than J. And so, critical path will again increase. The computation time of the nodes involved will get added. That is why it is important that you do retiming beforehand, I mean suitably, so that after unfolding also no new delay free paths emerge. So, this has some theory actually that I will not cover, but those who are interested, they can read something from Pari's book. Okay, then it is posed more like this, that after unfolding, if we want to have a particular critical path, that is the unfolded system should not have critical path greater than some value say C, then how should I do the retiming of the original DFG, so that after retiming when I unfold, the critical path of the unfolded system meets that requirement, that is not exceeding that amount C. Okay, this is a theory. This, if you are interested, you can see. Thank you very much. In the next step, I will carry on from here.